Okay, we have a reaction and we have some initial concentrations. Let's just say we put these things into a flask and we're wanting to know what's going to happen. How are these concentrations going to change? In other words, are we going to see more of this hydroiodic acid? Okay, and I have the Kc over here. This is the equilibrium constant for this reaction, and this is given as a known. I would assume probably at standard conditions, but whatever conditions we're using. And we're supposed to predict the direction of the reaction. So that's where our QC comes in handy. So we're going to calculate a QC, and then we'll compare it to the Kc, because that's where it will end up at equilibrium. That's like the goal of the reaction. So this is set up just like an equilibrium constant, products, and then I'm using this 2, I'm going to square that, reactants on bottom, these coefficients are 1, so I don't have an exponent shown there. These are all gases, and that's why they're all included. Gases and things that are in solution we count and include in our equilibrium constant and also in our reaction quotient, QC. So this would be Kc if I plugged in equilibrium concentrations. That would be the same thing. But I'm not. I'm just plugging in these numbers to see what I get, and then I'm going to compare with the equilibrium. So anyway, I'm going to plug in the numbers that were given. Remember on this week, just ignore units. It's just like the equilibrium constant. Units don't matter because this number is unitless as well. So I get a number, and then what I'm going to do is compare to my known equilibrium constant, which describes what the equilibrium should look like. And then if we'll remember that the equilibrium constant and QC are both products over reactants. And since the Kc obviously has more product, it's a larger number, so it must have more product and less reactant. It tells me that this number is too small. So the reaction will go to the right. In other words, when it reaches equilibrium, I'll have more of the hydroiodic acid than I do right now.